Hello everyone, welcome to our video. Today we are going to dive in a topic in Calculus 1 called differentiation. Now, if you have zero knowledge of calculus, don't worry. Here is the big idea. In the basic mathematics or algebra, you might be used of finding the slope of a straight line to see how steep it is. That slope stays constant, but in calculus, we often deal with curve, whereas the steepness is constantly changing. Differentiation in mathematical process we use to find the exact slope of the curve at any single specific point. It tells us the instantaneous rate of change, basically exactly how fast y is changing compared to x at the very moment. But before we jump into the problem solving questions, let us meet the team that will be guiding you through this journey. So, my name is Haninur Alisha binti Abdullah, and I am from CDCS 1103C.
Hello, my name is Izzati Najihah binti Arman. I'm from CDCS 1103C.
Hi, my name is Lukman Hakimi bin Muhammad Zaidi.
Hi, my name is Muhammad Balhadif bin Safi.
Let's look at the question 1A of a two function, which is we're gonna use product rules. Y equal to UV plus UV. So, first we're gonna identify two functions. Let U square root 2x minus 1 and V equal to sin 3 minus x. So to differentiate U, we rewrite it as U equal to 2x minus 1 power of 1 over 2. Then we're gonna use chain rule. So we cancel it into U 1 over square root x minus 1. And then for V, sin 3 minus x. So V equal to cos 3x times with 3 minus x. So we get minus cos 2 minus x. dy dx equal to uv plus uv. We sub it all. dy dx equal to 1 square root 2x minus 1 sin 3 minus x plus square root 2x minus 1 minus cos 3 minus x. Then dy dx sin 3 minus x over square root 2x minus 1 minus square root 2x minus 1 cos 3 minus 3 minus x. That's the final answer. Look at question 1b, use quotient rule, which is y equal to uv minus uv over v power of 2. So let u and 5x plus 1 and v equal to cos 2x. To differentiate the numerator, we use dy dx ln ax plus b equal to ax plus b, which is u will become 5 over 5x plus 1. And to differentiate the numerator, v equal to cos 2x, so cos we turn to minus c, change it. So v is minus 2 sin 2x. Then we substitute into the quotient rule. Y equal to 5 over 5x plus 1 cos 2x minus ln 5x plus 1 minus 2 sin 2x over cos power of 2 2x 5 cos 2x over 5x plus 1 plus 2 ln 5x plus 1 sin 2x. So the final answer is y equal to 5 cos 2x over 5x plus 1 plus 2 in 5x plus 1 sin 2x over cos 2x.
So now let's move on to question number 2. So this is the question that have been given. So I will guide you step by step. First one, you just write this. And step 2, apply the differentiation rule. This is the most important part. If you look at the middle of this page, we have split the problem into 4 small chunks, so it is not overwhelming. So this is the first one, first term of the left-hand side. Look at the first block on the left. We have 2y and ln in the bracket of 4x. Since they are multiplied, we have to use product rule. We differentiate the first part 2y to get 2 over 2 dy over dx. Then we differentiate the second part ln in the bracket of 4x. Notice that in the bracket we wrote 1 over x multiplied by 4, so we cancel the 4. So it gave us 1 over x. Multiplying it all together gives us the result 21 2ln in the bracket of 4x dy over dx plus 2y over x. So this is term number 2 of the left hand side. So moving to the right, we have 3x to the power of 7. We have to use power rule. we just multiply 7 by 3 to get 21 and drop the power to 6, and the result is 21x to the power of 6. Now move on to right hand side, term number 1. Now look at the text. Look at the next row. We have 2 times x in the bracket x minus 1. We have to use chain rule. The outside of tan becomes sec to the power of 2. We have to multiply the derivative of the inside bracket of in the bracket of x over y, which gave us 1 minus dy over dx. So this is the last one. Finally, the last part. We have negative e to the power of x to the power of 2. Again, we use chain rule. The e stays the same. We just need to multiply the derivative of the power of x to the power of 2, which is 2x. The result is negative 2x e to the power of x to the power of 2. Now, this is step 3. We combine and expand. If we look at the step 3, we have to take all those 4 answers we just found and stick them back into one long equation. We also expanded the brackets on the right so that every term is separate. So step number 4, we isolate the term. Now for the algebra, our goal is to find dy dx. In step 4, we have to move everyone around. See this term dy dx on the right, we move it to the left hand side and it becomes positive. And see the term without dy dx, the 2y over x and 21x to the power of 6. We move them to the right hand side and they become negative. Step 5, factor and solve. Okay, now on the left we pull the dy dx out to the front and factor it out. To get the final answer at the bottom, we just took everything in the square bracket and divided the right side by it. And there you have it, the final answer.
Hi, I'm Lukman and now I'm gonna show you how to solve question 3. So the first step is to define the general function fx and identify our best point x0. The function that models our expression is fx is equal to square root x minus 4 over cube root x. For the second step, we need to find x0 and delta x. We need an x0 close to 63.98 that is easy to work with. So we choose 64. Our base point is x0 equal to 64 and the change in x is the difference between our target value, and the base point is delta x equal to 63.98 minus 64, which is equal to negative 0.02. Now we move on with the next step. For the third step, we need to find the derivative. We need the derivative, which is f prime x. First, rewrite fx using exponents. Fx is equal to x1 over 2 minus 4x negative 1 over 3. We need to change it to f prime x. So this is how we do it. So it will become f prime x equal to 1 over 2 square root x plus 4 over 3 cube root x power of 4. Now, I'm going to pass the next step to Iqbal.
For the fourth step, we need to evaluate x0. We need to find f64 and f prime 64. To calculate f64, this is how you do it. f64 equals square root 64 minus 4 over cube root 64. Simplify it to become 8 minus 4 over 4, which is 8 minus 1, and it will become 7, so f64 equals 7. For f prime 64, we will do it like this. f prime 64 equals 1 over 2 square root 64 plus 4 over 3 cube root 64 power 4. Then simplify it and it will become 1 over 16 and 1 over 192. And the answer will be 13 over 192. For the fifth step, substitute them into the approximation formula. So 7 plus 13 over 192 multiplied with negative 0.02, and it will become 6.999 with 3 decimal places. For the last step, we need to check back using calculator. So just type square root 63.98 negative minus negative 4 over cube root 63.98, and you will get the same answer, which is 6.999. So this will be the final answer.